Okay, so in this video, you learn about natural logarithms and some of the key notation you need to be familiar with. So if I just start off with the laws, well, if we just have an exponential, let's say y is equal to a to the power of x, and we can rewrite this, and to find the value of x, we can say that, well, x is equal to the log of base a of y, and that will give us the value of x. So now in natural logarithms, let's say we have y is equal to e to the power of x. So when we have e, which is a special constant, and e is actually equal to 2.7182, and it goes on forever. So it goes on forever. And let's say if we were y is equal to e to the power of x, and we just approach it this way, and we say, well, x is equal to the log of base e of y. So now I'll write this down in green actually. So the log of base e is actually known as ln, and you write as ln. So this is the notation you need to be familiar with. So log of base e is equal to ln, and this only applies to natural logarithms. So whenever you have a base e, you use ln. So moving on. So if we rewrite this, we can rewrite this as, well. That means x is equal to a ln of y. If we just substitute ln for this, and therefore x is equal to ln of y. So let's say, let me give you an example. Let's say we have, well, y is equal to the ln of e to the power of x. Now, what's that value? So if we do it the long way, we can say, well, y is equal to log of base e of e to the x. Now, using the power law, we bring the x forward, and we say, well, y is equal to x log base e of e. And now we have the same bases. We can cancel. They cancel out to be 1. Therefore, well, x times 1, which is x. Therefore, y is equal to x. And so, I mean, you don't even need to do all these steps, these extra 2 steps. You can just straight away, tell from there, well, the ln of e is simply 1, and whatever the power is, you times it by 1. So if I have y is equal to ln of e to the 4x plus 5, I mean, this doesn't really make a difference either, because we have 4x plus 5. We know this is going to cancel out to be 1. So 4x plus 5 times by 1, hence we are just going to get 4. Y is equal to 4x plus 5. So now there we are approaching one of our second laws. We need to actually memorize this one, and well, this is x is equal to e to the power of ln x. Well, I mean, how did they even extract this? So if I show you how this was found, well, if you have y is equal to e to the power of ln x, well, if we just rearrange it like we did over here, we can say, ln of x is equal to log base e of y. And we know log base e, as I showed you over here, is ln. So we can say, well, ln of x is equal to ln of y. And if we divide by ln, we get x is equal to y. Now, because x is equal to y, we can substitute that in over here. That's right over here, and therefore we can get x is equal to e to the power of ln x. Now, for further understanding, I will demonstrate it on a graph. So here's the graph of y is equal to e of x. It's an increasing curve because it's a growth curve as e is greater than 1. It's 2.7182, as I mentioned earlier. So if we take the graph of y is equal to e of x and we reflect it in the line y is equal to x, I mean, we get the inverse function, which is equal to y is equal to ln x. So the inverse of y is equal to e to the x is ln x. And we found that out by drawing a line y is equal to x and reflecting this graph onto the opposite side. Okay, so moving on to some examples. Let's say we have 3e to the power of 4x is equal to 1. And we have a coefficient in front of e, which is 3. So we're going to divide both sides by 3. And then we get e to the power of 4x is equal to 1/3. So now we want to use the first principle we learned, which is taking ln or log on both sides, and we get 1. It simplifies to be 1. So if I can demonstrate that to you, well, ln of e to the 4x is equal to the ln of 1/3, and hence this will just cancel out to be 1. Multiplying this by 1, we get 4x. So we get, well, 4x is equal to the ln of 1/3, hence x is equal to 1/4 of ln of 1/3, or you can say ln of 1/3 divided by 4. Okay, so now if we move on to the second example, which will be the ln of 4x is equal to 1. So now really, I mean, how would we go about solving this? We have to pay attention to the second law, the second principle we looked at, which was e to the power of ln x. Over here, we can't take the log on both sides because there's already a log function over here. Hence, we can do this. We can say e to the power of ln x, so we can write e as the base for both of them, and we can raise them to the power. So e to the power of ln x is equal to e to the power of 1. So I just put an e over here and I put an e over here. And why I done this is, well, we know that this is just going to simplify to be 4x. And how is that? Well, 4x is going to be fed into the log function, and then the log function is going to be fed into e, and then these are just going to cancel out because they are inverse to each other, and hence we are going to be left over with 4x. So we're going to say 4x is equal to e, and hence e is then going to be equal to, x is going to be equal to e divided by 4. So moving on to the third example, we'll have e to the 2x is equal to 25. Now over here we have e, so we can take the log on both sides. We can take the natural log because we have the base e. Therefore, ln of e to 2x is equal to the ln of 25. Now we know this is just going to simplify to be 1. So we can say, well, 2x is equal to the ln of 25, and then x is equal to the ln of 25 divided by 2, or we can say, well, for further simplification, we can say, well, a half times by ln of 25. Now by using the power rule, we can say that, well, we can bring the half above the 25, so we can say, well, the x is equal to the ln of 25 to the power of a half, and we know the power of a half basically means square root, so x is equal to the ln of 5. And this is the fully simplified answer. So an alternative for this same answer would be, well, I'll do it below over here. I'll do it over here, the alternative, so I'll make a star. If we have e to the power of 2x is equal to 25, we can times the powers by a half. If there was a 3 over here, we were going to times the powers by 1/3. If there was a 4 over here, we were going to times the powers by 1/4, and you get the deal. So e to the power of 2x times by a half is equal to 25 times by a half. Now, as I previously said, if there was a 4 over here, you were going to times this by 4. I hope this doesn't confuse any of you. So if we get e to the power of x is therefore equal to 5, taking the ln on both sides, ln of e to the power of x is equal to the ln of 5, and hence x is equal to the ln of 5. And this is just a different way of approaching. Well, if we have example number 4, 3 to the power of x multiplied by e to the 4x minus 1 is equal to 5. Now we can take ln on both sides. So what we can say is, well, the ln of 3 to the power of x e to the power of 4x minus 1 is equal to ln of 5. Okay, so we know if we can recall the multiplication law, we can just split these two up because they're multiplied, and we can add them. So we can say, well, the ln of 3x plus the ln of e to the 4x minus 1 is equal to ln of 5. Now, hold on a minute. Well, this looks quite familiar. We just done this in the previous example. So we can say, well, the ln of 3, and we can bring that x over using the power rule. We just brought this x over. So plus, this is just going to multiply to be 1. Multiply this by 1, we're going to get 4x minus 1 is equal to the ln of 5. Now, if I take the 1 over, I can say, Well, the x of ln 3 plus 4x is equal to ln 5 plus 1. Now we can see something common about these two, and that's the x. So we can factorize the x out. We can say the x factorize out ln 3 plus 4 is equal to the ln of 5 plus 1. And hence we can say x is equal to the ln of 5 plus 1 divided by the ln of 3 plus 4. And that would be the exact answer.